Okay, again, we've been talking about matter. All matter has energy, so all matter has the ability to do work or transfer heat. And we know that all matter, when it comes to energy, will have potential energy or kinetic energy. Potential or kinetic. And I've done a demonstration for you on potential energy and kinetic energy. We can see that all matter has energy when a chemical reaction has taken place. We can mix two things together and there is a transfer of heat, usually is what we'll see. And if there's a transfer of heat, then there's a temperature change. In order for chemical reactions to take place, we need to have enough activation energy to get the chemical reaction going, so we need enough energy to get it going. But once we get the chemical reaction going, there's usually a temperature change, or then we can actually measure that. Usually we use Celsius. Kelvin is also used in chemistry. So in chemical reactions, if there's a chemical, or if there's a temperature change, heat is going to be absorbed. If that's the case, that's endothermic and the temperature gets colder. Or energy could be released, that's an exothermic reaction, and the temperature got hotter. We measure this energy using calories or joules. So in a chemical reaction, there's temperature changes, but to measure the energy that was in the matter, we use calories or joules. So the unit of energy is calories or joules. Calorie is the heat needed to raise 1 gram of water by 1 degree Celsius. So 1 cal is equal to 1 gram times 1 degree Celsius. The following is the conversion factor between calories and joules. If you have 1 calorie, you have 4.184 joules. Calorie, joules. You may have heard of calories before when it comes to your food. There is energy in food. Your food is matter. All matter has energy. We measure this energy in either calories or joules. The dietary calorie, or the calorie we know in our food, is 1,000 times as large as the calorie we use in chemistry. The calorie in our food is known as a dietary calorie and is actually technically a kilocalorie. So think of calorie as the base, kilocalorie 1,000 times larger. That's the dietary calorie. The following is the conversion factor for calorie and the dietary calorie. So big calorie versus little calorie. 1 big calorie, and you see that the C is capital, is equal to 1,000 little calories. You can see that the C is small. There's that conversion factor which you will be using. So here's just some practice problems we will be doing. Okay. You have a potato, you have a 200-gram potato. It has an energy value of 686,000 joules. What is that value expressed in the little calorie, or the chemistry calorie, versus the dietary calorie, or the big calorie? So we're going to do two separate problems here. Okay. So we write down the number given to us. That's always the first step. Joules. Okay. The second step is to make the T-chart. The third step is to get rid of the value you need to get rid of. If we want to get rid of joules, it has to sit down here to cancel. The value we are trying to find always sits on top. We'll look for the little calorie first. This needs to be written fairly neat because I need to be able to tell if that is a little c or if this is a big C. There is a difference. We're finding the little calorie first. This is the conversion factor. Oops, sorry. We're using this conversion factor right here because we are going from calories, joules to calories, joules to calories. So we have 4.184 joules in 1 little calorie. We can punch that into our calculator, and again, we do not look here, or here for significant digits. These are the constants. This is a conversion factor. We do not look at the conversion factors. When we're doing significant digits. We go back to the original number, the original problem. We should have 3 significant digits. I'm always going to go back and double check my labels. Joules cancels, I'm left with little calorie. That is what I was wanting to find. Okay, so the next problem was to find how the energy value. We have 686,000 joules. We're going to change that to our dietary calorie or our large calorie. So write down the number given to you. I don't have the conversion factors directly from joules to large calorie, but I can go to joules to small calorie. Okay, if I would stop there, all I found was small calorie. I want the large calorie or the dietary calorie, so I'm going from small calorie to large calorie. I'm going to cancel. I have large calorie left. That's how I know I set the problem up. Now I just put the numbers in. And these numbers have been given to you. 1 calorie is equal to 4.184 joules. So small calorie is actually larger than a joule because many joules fit into that. And we have 1 big calorie and you have 1,000 small calories. You punch that into your calculator. And again, we go back to the original number, 686,000. There's 3 significant digits. And my label, I can tell that that is a big C. Okay, given the number, write down the number given to you. Joules to little calorie. You can put that in your calculator and you would need 2 significant digits. We would need 2 significant digits. I need to grab my calculator. 250 4.184. So we need 2 significant digits. This is what the calculator spit out. Okay, but we have to get that in 2 significant digits. So there's 1, there's 2. I look next door, this has to round up, so then we get 60. That's still not 2 significant digits, so I'm going to write this as that's the only way I can get 60 into 2 significant digits. Okay? Okay, the last problem, 37.5 calories to joules. I'm going to have to do it off to the side here. So the first thing I'm going to do is write down the number given to me. I'm going to change that calories to joules. So the calories has to go on the bottom so it can cancel. I'm looking for joules. The item I'm trying to find always sits on top. I know that there's 1 calorie. And there's 4.184 joules. Okay, I need 3 significant digits because 37.5 is 3 significant digits. This turns out to be, the calculator number was 156.9. There's 1, there's 2, there's 3 significant digits. I look next door. That has to round up, so 157. Go back. Joules is my final answer. And was that, oh, yep, I was trying to find joules. Okay. Again, if there are any types of questions on this. This is just converting like we've been doing. You just follow the steps. Write down the number given to you. Make your T-chart. What you're trying to get rid of goes on the bottom. What you're trying to find goes on top. Multiply straight across the top. You multiply straight across the bottom. You divide. You get your answer. You go back to the original problem. You look to see what the number is in the original problem. You don't look at the conversion factors. And then you write your answer in significant digits.